Simplifying algebraic expressions with fractions. This is a digital lesson, and this is really important to give this to students. It's a good review of fractions before they go into solving algebraic equations with fractions. So the lesson starts with example number 1. If the denominators are the same, you can add or subtract the numerators. So here's a couple examples. The denominator's 5, so I can just add the numerators, keep the denominator the same, and then I simplify 25 divided by 5, gives me an answer of 5y. Here again, denominators are the same, I can add the numerators, and then simplify. Next slide has a couple of subtraction problems. Then students are going to try these on their own. They've got 4 problems they need to solve. They're just going to type in the text boxes. So here the denominators are the same, so I can just add the numerators, keep the same denominator, simplify, I get 3y. So they've got a few of those to solve. Example number 2, multiply the fraction of each term inside the parentheses. So here we're using the distributive property with fractions. So we're going to distribute this 1/2 to both terms in the parentheses. So they can see that this is 1/2 times negative 12s plus 1/2 times 6. So we're going to do these separately. If I multiply here, I'm going to get negative 12s over 2. And I can simplify this negative 12 divided by 2 to negative 6. So negative 6s. Here, 1/2 times 6 gives me 3. And this is my answer. Same thing on the next one. I'm going to take 1/3 times the first term and 1/3, subtract 1/3 times the second term. And students have 4 of these to practice. Now example number 3, sometimes we need to change the order of the terms using the commutative property so that like terms are next to each other. It makes it a little bit easier to solve. So here is our expression. These 2 terms are like terms, so I'm just going to move them so that these 2 are next to each other and add that 3y last. The denominators are the same, so I can just add 2x plus 4x, and I can get 6x over 12 plus 3y, and the last thing to do is just simplify 6 over 12 to 1/2. And then students have a couple of these to solve. So here's one of them. I just changed the order, so all they're going to do is type in 5a over 7 and 9a over 7 and add that 7b last. So for example, on the next one, I'm going to just type in 8x over 5. I'm going to add the 7x over 5 next, just changing the order, and then the 9y last. Here the denominators are the same, so I can add the numerators. And then I can simplify 15/5 to 3x plus 9y. And that's as far as I can go because the variables are different. Example number 4, I want to separate the fractions into 2 separate fractions and then solve. So here I have 16x plus 8y over 4. I can separate that into 2 different fractions. 16x over 4 plus 8y over 4. And then to simplify here, 16 divided by 4, I end up with 4x, 8y divided by 4, and I get 2y. And that's as far as I can go because the variables are different. And they've got a couple more examples, and then they're going to try these on their own. Example number 5. If the denominators are different, change one or both of the fractions into equivalent fractions with like denominators. So here, I don't need to change this fraction, but I do need to change this one so I can get 15 in the denominator. And I'm going to do that by multiplying numerator and denominator by 3. So I get 6x over 15 plus 7x over 15, and now I can go ahead and solve it. And then if you can simplify, you want to simplify. In this case, you can't because 13 is a prime number. And here's another example. This is an example when you need to change both fractions. in order to get the same denominator. So I'm going to multiply this first fraction times 3, numerator and denominator, times 3. This one, numerator and denominator, times 5. And then I end up with a denominator of 15 on both fractions. Now I can add the numerators. And again, if you can simplify, go ahead and simplify. So students are going to try this on their own. This part's already done for them. It shows them what to multiply to get both denominators of 10. And then this one, we want to change both fractions to have a denominator of 30. And then this one, they're going to have to figure out how to do this on their own. What do they have to multiply to get a like denominator, and then go ahead and solve it. Now, for students who need a little bit of a challenge, we've given them this one. So they're going to need scratch paper to figure this out and then type the answer at the bottom. So this one's a little bit tricky. They're going to have to distribute and then use all of the tools that they just learned from the lesson in order to solve it. So this is a digital lesson, simplifying algebraic expressions with fractions. And I've also included a worksheet to follow the digital lesson.